Okay, so this video is going to be about creating a rhythm game. Specifically, we're going to have an image that's meant to be a guitar, and what's going to happen is there's 6 strings, so in each string a note will appear. That marker will move along the string, and then at a certain point you're supposed to hit the corresponding key to represent the strumming of that string. So let's get right into it. All I've done so far is I just imported these 2 images. I imported them, and this is a particle system. I did create it. I usually don't review the creation of them. If you want, since I've highlighted it, you can look at some of the settings, but in short, it's just a very quick burst of really tiny particles. So you've got quarter second duration, half a second lifetime, start size. This is the default particle that comes with Unity. It's a 0.18 size only, so you're talking a very small, sharp burst, and from this line you can see that it is set as green. So let's get started. First we're going to drag and drop the guitar image into the scene. We're going to just modify this. This I realized by trial and error that when I had drawn the image it really wasn't quite as large as I wanted it to be. So you might not have to do this step when you use your image if you make it the right size to begin with. Okay, now what we're going to do is we're going to drag and drop the circle image into here. What I'm going to do is I'm going to create 6 of these, 1 for each note. Now you could say, well, why don't you just make 1 and have it instantiate on all the other ones? And the reason, and have it instantiate along the top, the reason why I'm going to make 6 instead of 1 is this allows us to make a decision based on the name of the object. It also lets us make decisions as far as the velocity based on the name of the object. So yes, you could do it with just 1, but by making 1 for each string, I found that it actually simplified a lot of things. So what we're going to do is we're going to create each one and we're going to line them up with the corresponding strings. So we're going to add a component, Physics 2D, Circle Collider, and I'm going to shrink that in just a little bit. Again, depending on the size of the image you're using, you might not have to do that. It should be a trigger because we don't want it to collide, we want it to overlap other objects. And let's see what else. It needs a rigid body, so Physics 2D, rigid body 2D. We do not want any gravity scale. And you could say, well, you know, it's going from the top to the bottom of the screen. Why don't you use the built-in gravity? It's problematic and you don't have as much control over it. So by setting the gravity to 0, you can manually set the horizontal and vertical velocity without any interference. Your mileage may vary. You may find it easier to use the gravity scale. I personally am not, but do whatever works for you. So we added a circle collider, made it a trigger, added a rigid body, removed the gravity scale. That should just about do it. I'm just going to go over to my text file to remind myself what I named them. And don't worry about this code. We're going to go through that in its entirety. Okay, looks like I used S1, S2, S3 in the note. So we'll call this S1 and then note. And the reason for S would be string 1, and then S2 string 2, so on and so forth. It's going to need one other thing. It's going to need a script, but all 6 notes are going to have the same script, so we can always add those at once. So we're just going to copy, paste, just change the digit to 2, so S2 note, so string 2 note. Slide that over. Copy, paste, S3 note, so for the 3rd string, S4 note, S5, and then one final one, S6. Now looking at these, I think the size is just a little bit too big. So what happens is, if you change the scale of an individual object, it changes just that object. If you change the size of the asset, the image that's used for the sprite, it will change all of these at once. So we're just going to change this to pixels per unit. Since it's a ratio, if you increase it, then the object gets smaller. So let's bump that up to 140. And you can see they all shrunk a little bit. Okay, so there's going to be two scripts. One is going to be on the guitar itself, which is going to, based on how much time has elapsed, which string a note should appear on. The other script is going to control the motion of the notes themselves. So let's start with that, but then we'll jump to the other one partway through. So let's right click down here, choose Create, C#, and let's just call it Note Control. And again, like I said, don't worry about all the text there. We're going to go through it one at a time. So let's go ahead and open Note Control. And the first thing that we're going to add is this variable, public transform burst. So since it's a transform, you know it's an object. So let's go ahead and save that. Then, since I haven't actually applied it yet, let's highlight all the notes, drag and drop the note control onto it. So they all now have the script, and now they're all looking for that. They're all highlighted, so we could do the same thing with the particle system. We'll just drag and drop it there. So what we've done is we've taken this particle system, which, like I said, is just a quick little burst of green dots to represent a successful note. So what's going to happen is, now that the note is aware of it, they can instantiate it, which is necessary. So if you get a note correct, the note should disappear, the burst should appear, and then the burst will disappear on its own. So that was simple. Next part. This goes in the start section. I'm going to paste it all at once, but don't worry, we will dissect it. So in the start section, so this happens every single time the note is instantiated. So this script is on the notes. So every time the note gets instantiated, this will occur. So let's see what it does. So first of all, whenever you instantiate an object, whatever the name of that object is, and there, I haven't turned them into prefabs yet. We will in a minute. But when you instantiate an object, whatever the name of the object is, that's the name of the object, but it also appends the word clone to it. So let's go ahead and drag and drop these now. One at a time, S1, S2, S3, S4, S5, and S6. We can now delete those. So whenever these get instantiated, it gets instantiated with that name appended with the word clone. That's why it's S1 note clone, S2 note clone. You could take the time to, upon instantiation, rename it and get rid of the word clone, but honestly, we don't check it that much, so it's not that big of a deal. Okay, so if the game object name is S1 note clone, then modify the rigid body, specifically the velocity, and it wants a new velocity, negative 0.21, negative 1, 0, so ever so slightly moving to the left, moving down, and not moving on the z-axis. GameObject.name equals S2 note clone. Same thing, get component rigid body, change the velocity. This time it's not moving left as much, moving down the same speed. And just on and on for all the nodes, S3, S4, S5, S6. Partway through here, if you notice the number becomes positive. So that's S4 note. So if you look at the strings, 1, 2, 3, 4, you notice that it is now sloping to the right, not to the left. That's why the X is now positive. So that's what that does. That simply gives the velocity to the individual notes. Now we're going to go to the other script first, because what remains is dependent upon it. So the second script, just right click, create, C#, and we'll call this song control, because this is really what's going to determine what notes get instantiated where and when. Now, let's go ahead and open that up. We'll go to the text file again. So first things first. We need to create a whole bunch of variables. So, public transform, so it's an object, note 1, 2, 3, 4, 5, 6. So that's self-explanatory. What that's saying is that this script is attached to an object, the guitar object. That guitar object is going to need to be able to modify these in some capacity. Specifically, it's going to need to instantiate them. So click on the guitar, and we just have to drag and drop the script onto it. As you can see, it's now looking for those objects. So just drop them on the corresponding one. S1 note goes to note 1. And if you're wondering why I didn't name it exactly the same, at times when you're looking for, when you're typing out the code and it gives recommendations as to what you're trying to finish, it does the suggestions. If you have these names be the same, you might not be sure what you're looking at. It's like, okay, am I looking at a script name? Am I looking at what type of object am I looking at when the script is making a recommendation? So by making these different enough, you will always be able to keep track of what you're looking at when the script recommends a suggestion. Okay, so note 1, 2, 3, 4, 5, 6, note 1, 2, 3, 4, 5, 6. Okay, next. And I think I've mentioned before, you don't need to leave spaces in this. I just try to group similar types of variables. Don't have to, I just do because I think it makes more sense to me when I'm troubleshooting it. So, public float, song length equals 0. This is going to be a running cum for the duration of the song that you're trying to play, and this is going to be used to determine what note should be instantiated when and where. This you're probably going to do slightly different. This is where you put in the key code. So key code, key A, key code, key S. You do not have to name the variable the name of the key. I just did that so I would remember. So when this is completely spelled out, each a key will correspond, a key in the keyboard will correspond to a string. So just left to right, A, S, D, F, G, H. So I only put 2 in here. We'll put in another, but ultimately it's going to be a key for each one. So let's save that and you'll see what happens. So the script is attached to the guitar. We create those variables, so now it wants you to assign a key. And again, you don't have to put the key name into this. That's just because I was trying to keep straight in my head everything that I was going to do with this. Okay. Now, and the last grouping of variables, public static string destroy A equals no, destroy B, C, D, E, F. Okay, so again, we're looking at 6 notes. So here I swapped from 1 to A, 2 to B, 3 to C. Again, because like I said, I want to make sure I know what I'm looking at when the script does recommendations. So what's going to happen is this is how, since it's static, any script on any object anywhere will be able to read this. So what's going to happen is this variable will be set to yes when you want to destroy A, set to yes when you want to destroy B, set to yes when you want to destroy C. Okay? As we said, the notes going across left to right, 1 through 6, A through F, although on the actual key on the keyboard is different. That's A, S, D, so on and so forth. Okay, so this is saying destroy that note. And then what's going to happen is in our note control, we're going to have a check for that and say, okay, if this is set to yes, then auto destruct. Not quite there yet, though. So we'll save that. Nothing in start. Now this time we're going to use fixed update since timing is has to be precise. We'll use fixed update instead of regular update, and we'll get rid of start as well since we're not using it. Whatever you're doing, you're probably going to need the start. We don't need it in this demonstration. So let's break this down. So with every frame, fixed update runs. Song length, we define that here, declared it here. Add to it time.delta time. So whatever amount of time has passed, dump it into this and increase this by that amount. So when you're 5 seconds into the song, this will be 5. When you're 20 seconds into the song, this will be 20. So on and so forth. This is going to be a running cum. You're not going to reset it. And now, the actual scripting of the notes appearing consistently in a certain order. So, if song length, again this variable, is greater than or equal to 0.1 and song length is less than or equal to 0.125. So why did I create a range? Because in all likelihood you're not going to get the exact timestamp you're looking for, so you create an ever so slight range. And by doing that, it'll only appear once in that range. This was trial and error where I found out, okay, that 0.025, that was a safe amount of time to make the note appear without a risk of there being 2 notes appearing. Okay, so if song length is within that bracket, instantiate. This is entirely up to you as far as what note you want to instantiate. So I said that, okay, we're going to instantiate note 1. Where's it going to instantiate? The default position for note 1, and it's going to use note 1's rotation. You have to declare position, you have to declare rotation. Now, let's take a look what that means. When we created these, remember what we did? We lined them up with the strings to begin with. Well, that is the position that was used when I then turned them into prefabs. So if you click on them, that's what these numbers are. Now you can just manually change this if you want to, but obviously it's easier to line it up on the screen before you create a prefab. So that's what it's using when you say the name of the variable dot position. So instantiate note 1 at note 1's default position with note 1's rotation. And then it's just a matter of choosing when you want the other notes to appear. If song length is greater than or equal to 1 and song length is less than or equal to 1.025. Again, I'm using a 0.025 range. Instantiate note 2. Didn't have to be note 2, you could do note 5, note 6. That's all the game balance. That's all what you're trying to do. And this is just rinse and repeat. You get the next bracket. And this one's note 6, this one's note 5, this one's note 4, whatever you want. And then you just rinse and repeat for the entire song. Let's go ahead and save that. Last thing for this one. So outside of fixed update, outside of start, although we're not using start in this one, you create a whole new subroutine. Void on trigger stay 2D collider 2D other. Very important. This is a pre-existing coroutine, so you'll absolutely have to spell this out correctly. Capital O, capital T, capital S, capital D, collider 2D, and then the variable other. What this is saying is, so long as a collision is occurring, we want certain things to happen. Okay, so long as a collision continues to occur, well, we're not just going to automatically do something, we're going to make some checks. So while a collision is occurring, we're going to say, okay, is key A being pressed? Yes or no? And if the other game object is S1, no. So what this is saying, okay, so this script is attached to the guitar. We're going to add a collision zone in a few minutes. Okay, we're going to add a collider box. What it's saying is that if the other object that's colliding with the guitar is note 1 and you're pressing key A, because as we said, key A is going to correspond to string 1 to note 1, then go ahead and set destroy A to yes. Now why don't we just destroy the object? Because you'll get an error message saying that you can't destroy it. Because what happens is when you try to do a destroy game object, it tries to destroy the actual prefab. So there's probably a way when you can just destroy it here. I was never able to get it work, so it's really not any more difficult just to create a static variable and have the object destroy itself. In some ways I kind of like that. I like all the functionality of an object being contained within it, as far as behaviors and things like that. So let's save that. Next one. Again, this is only occurring so long as there's a collision. This time it's saying, okay, if key S is being pressed, as we said, the S key would be for the second string, and the game object that's colliding, again, other. In this case, is it S2? Then go ahead and set destroy B to yes. So if you're pressing A while there's a collision, and S1 happens to be the object doing the colliding, in other words, you're looking at a matching between the corresponding key A and its note, key S and its note, key D and its note. So you're just looking at corresponding notes and the key that's meant to represent you strumming the string. So the question is, why does this work? So let's go to the guitar object. I'm going to add a component. I'm going to add physics 2D. I'm going to add a box collider, and then we're going to modify it. So what's going on is this. There's two ways to do this. There's a very difficult way, or at least a more difficult way, where what you do is you keep track of exactly what the next note is that needs to be pressed. Because if you make this collider box big enough, then you could actually have multiple boxes collide, multiple notes colliding, and this falls apart. This would stop working. So you'd have to have a note, you'd have to have another variable that tracks, okay, what's the next note you're supposed to press. Instead of doing that, so like I said, that's the complicated version. Instead of doing that, if you design this so that only one note is colliding at a time, then you don't have to track what the next note is. The next note is whatever's colliding. So that might sound a little bit loopy. Once it's playing, it'll make more sense. But if you set this so only one note can be declining, then inherently that note has to be the right note. Now that we finish that, we can come back to our other ones, because as I said, we had to stop where we were because it was reliant upon the other script. Alright, so song control is completed. Now we're going to go back to the note control, and this is going to be the update section. So here's that variable we're talking about. It's a static variable, so any script, any object can access it as long as you tell the script, the object, where it is. So the variable is destroy A. It's located in song control. If you recall song control up here, that's where we define them. So if you're trying to check for a static variable, you have to say what script it's in, and then you have to put in the name of the variable. So if songcontrol.destroyA is set to yes, and gameObject.name is s1 note, and then as we said it's a clone when it's instantiated, do a couple things. Destroy the game object, in other words this is attached to the note, so it's going to destroy the note. 2. Instantiate the burst. So instantiate, as you recall, that was the only variable on the note, is the burst, and it's the particle system. So instantiate the particle system, transform.position, burst rotation. So if you notice, this is different. In the other one we used the position of the note. We don't want to use the position of the actually, let me rephrase that. So in that we used, when we instantiated, we instantiated at the top of the guitar, and we wanted to use the note's position. In the case we're actually using the note's position, what we're not using is the particle system's position, because if you notice it doesn't say burst.position, it says transform.position. So this is actually grabbing, because this script is attached to the note, it's grabbing the position of the note. So a little bit different. The other one we wanted to use the prefab's own position. This one we don't want the prefab's position. We want the position of the object that it's instantiating it. And then this is just rinse and repeat. If songcontrol.destroyB is equal to yes, gameObject.name is equal to s2 note clone, and gameObject name is s2 clone. Again, destroy the game object and instantiate burst. So you're just going to do one for each note. So let's can do another one. So if destroy C is set to yes and game object is S3, destroy the game object, instantiate the burst. Now we're going to do one more thing. Games like this, I personally don't play rhythm games, but based on the videos that I've seen, it looks like it provides information to the players to when it's time to hit the note. So let's grab that. Okay, two more subroutines. Void on trigger enter 2D. Again, this is a pre-established routine, so you need to have this exactly right. Capital O, capital T. If you notice, it's not stay like the other one, it's enter. Enter is the single frame in which this occurs. So on trigger enter 2D. So you're saying that if, again, this is attached to the note, not the guitar. So if the note is overlapping with another trigger, get component, sprite renderer, color, new color, green. So because zeros are, the first variable is R, the second one's G, the last one's B. So RGB, we're saying make it green. That's why it's white to begin with. Void on trigger exit 2D. another pre-established, pre-existing coroutine, so needs to be named correctly. So this is what you do when the note enters the collider zone that we made on the guitar. You're going to change it to green. Void Untitled 2D, you now turn it to red because the first one is red. And then what you do is you destroy the game object after a quarter of a second delay. So I don't know if we've seen this before. So you see destroy game object like here, okay? But there's actually another argument here that is optional, and that is you can create a delay. So rather than having to use time.delta time or IE numerator, you can just say wait a quarter of a second before it gets destroyed. It's a fraction, so make sure the F is there, or a decimal, so make sure the F is there. That should do it. Now this should work, so we're going to play it through a couple times so you can see what happens. So based on time, it's instantiating the notes. When the note gets far enough, it turns green, and then turn red, and then disappears. In addition to turning red, so that's right here, destroy game object, you could do something else that if you have like some kind of sound effect, you had to play the sound here that says, maybe the sound of the audience booing or something, or something that's sounds like a note being strummed incorrectly. Whatever flourish you want to use, it would be in here. So now let's run it again, and now I'm going to hit the keys. Okay, and it's working.